Hello everybody, and welcome to today's presentation, Application Security for the Modern Web, brought to you by Signal Sciences. I'd like to introduce you to our presenter, Phillip Maddox. Phillip is a trusted AppSec advisor and senior solutions engineer at Signal Sciences. He has over 10 years of experience in information security, with the majority of that time focused on application security in the financial services sector. In his spare time, he enjoys converting ideas to code and committing them to GitHub.
Thanks, Billy. And hello, everyone. So to start out, just a quick bit about me. I am a AppSec researcher and advisor at Signal Sciences, and I work with a handful of our large enterprise customers on a daily basis to help them with some of the threats that they're facing. You can also find me on Twitter and, as mentioned, GitHub, but there's the address there for GitHub. And then just a quick career summary, as it was already mentioned, but spent a majority of my AppSec time in the financials in the Northeast with Ernst & Young and Goldman Sachs. And actually, a part of this presentation, I'm sharing a little bit of that experience with you. And then also, I'm a honeypot enthusiast. So I have actually a couple of projects out there, HoneyPie, HoneyDB, and you can find those also if you go to the GitHub site, you'll be able to find those. So with that, let's jump into it. So today's agenda, first I'd like to talk about the modern web and kind of my perspective on that. And then I want to share my observations for the Secure SDLC. So this is based on my experience of doing AppSec throughout my career. And then I want to talk about legacy threat visibility, which and some of the challenges we face with that. And then I want to talk about moving forward in the modern web. And basically what this is about is describing what we should be looking for in a solution or solutions to defend our applications in the modern web. And then just a quick note, I do have some survey questions that will be scattered a little bit throughout the first part of this presentation, so just be ready for that. All right, so describing the modern web. So I break it down into these kind of three, pillars, for lack of a better term, but these three categories. So the first is frameworks and architecture. So we're seeing a lot of client-side, JavaScript-heavy applications, single-page web applications, and so that's a big part of it. And then on the server side, we're moving to microservices, and the majority of it's API driven. Even more recently, we're seeing move towards mesh networks and things like that. So that's the first piece of the modern web. The second piece is about process. These are the processes that drive the modern web. So your agile development cycles, things are moving faster, deploying faster. CI/CD, and then DevOps, of course. All those I'm sure are very familiar terms, but yeah, so that's really about the process of that's driving the modern web. And then platforms. So cloud being a big part of that. There's a major shift to the cloud in recent years, certainly with IaaS and also the PaaS, the platforms as a service. And certainly containers and of course Kubernetes make a big piece of that. So to sum it up, this is the three parts of the modern web, at least as I see it. And to sum it up, in one clean statement, the modern web is about services, frequent deployments, and scalability. So that actually brings us to our first survey question. The modern web is about services, frequent deployments, and scalability. And in this survey, I'm asking, do you agree with that? Do you partially agree with that? Or perhaps you completely disagree with that? We'll give a few minutes so responses can collect. But I always like to get this type of feedback when speaking about this topic, and obviously with this presentation. Definitely want to check myself, keep myself honest And so your feedback is appreciated.
I'll give a couple more seconds for those last few responses. And here are the results for that poll.
Great. Cool. So 85% agree, 15% partially agree, and at least there's 0% disagreeing. So, so at least I think I'm still on the right track with things. All right. I believe my slide should be displaying again, but someone, if not, please let me know. All right.
Yes,
so,
they are.
Great. Perfect. Thank you. So moving on to observations of the Secure SDLC, and again, this is based on my experience. So way back in the day, starting out with early AppSec programs, trying to figure out and define what what's involved in those programs. I have this ML1, which ML stands for maturity level. So maturity level 1, maturity level 2, and maturity level 3 as we go down on this deck. And so in the early days, app teams were coding their apps and then, deploying them into QA, doing their testing, and then notifying us at that point that, hey, we're going to be deploying to production, within 4 weeks or sometimes even less. So InfoSec teams or, AppSec teams were scrambling to, at the tail end, at the development lifecycle, check the application for vulnerabilities, right, that could expose us to attack. Pieces of that was, reviewing architecture, doing manual pen testing, or in some cases, dynamic pen testing with scanning tools and things like that. And producing a set of findings, and then hopefully having about 2 weeks to work with the app team to remediate any vulnerabilities that were identified before going to prod. So we were kind of like right at the tail end of the process. It wasn't great. It was stressful for everyone, and especially when those list of findings came out with a little bit of time to remediate them. And so the negotiations began. So it was not a great process, just not the most streamlined process, and didn't work very well for everybody. So we try to improve, right? We're always trying to improve. So eventually we kind of looked at, well, what can we do earlier in the process? And so that takes us to this ML2. So we try to implement, static code analysis, code scanning earlier on, as code's getting committed or what have you, or the developers are running it themselves. And producing reports from that and trying to remediate those before going to QA. And then, continuing once it goes to QA, we kind of continue with that same process of pen testing, and then also working through remediation. So, moving further left in the development lifecycle with the code scanning definitely helped to find some issues earlier on. So we would have less findings in QA, which meant less findings to remediate before going to prod. And then, so as my career progressed, we got a little better in defining and engaging in the process earlier. So, early on, we would try to engage with the app teams to do architecture review. Hopefully before they began coding, but mostly not. So just to have that, architecture review done to ensure that proper controls are being planned for and in place, and then still continuing on with the code review, which in this case could be a manual code review, and then code scanning, of course, and then continuing on with the process. So so this is kind of over the last, I guess, almost a decade working towards that ML3. So actually, I'd like to pause here with another survey question, and I would love to understand the Secure SDLC that closely resembles, what goes on in your organization today. So is it more of an ML1, an ML2, ML3, or you don't have a Secure SDLC process, or you're just way ahead of the game and you're doing more than what I described here. While you're filling that out, I'll just share that, in other times I've given this presentation, it has been, mostly more towards the ML1 or ML2, which, sometimes I'm surprised by that, but I know, a lot of organizations are still working towards improving their AppSec practices.
And here are the results from that poll.
Okay, great. So 21% at ML1 and ML2, 21% as well. ML3, right around the same number. Oh, surprisingly, a little bit surprising that there's 32% that don't have a secure SDLC process. And I'm, I'm an AppSec head, so that's why I say it's surprising. So it might be surprising for me, but perhaps across the board, it shouldn't be surprising. And then, okay, 7% with a more advanced, process, and that's awesome. So that's good to see. Cool, thank you. Right. All right, so this is my ML4, which is, the ultimate secure SDLC fantasy. So to kind of walk you through this, you have your architecture review and threat modeling very early on. In the development phase, you've got in IDE SAS, so static code analysis, while the developer is actually writing the code. And then build integration environments. You have additional SAS running, secure unit testing, so actually creating unit tests for validating security controls. Dependency checking, so this is looking at third-party libraries for vulnerabilities that might be lurking in those libraries. And then as you move to like a test environment, you have your manual code review, and then getting to QA, again, you have your DAS, but also adding runtime analysis, and then manual penetration testing, of course. And then into production, threat visibility, and we're going to talk more about this later on. And also attack mitigation. So you have kind of that visibility of what's happening, and then of course mitigations to, again, to fend off attacks, and also central logging to have that capability with the logs centralized and collected, so they can be analyzed if necessary. And these arrows pointing back to our developers, operations, and security, right? So these are representing basically a feedback loop, right? So this information is getting back to these individuals as a part of the process. Notice the developer is getting a lot of the feedback, obviously because they're the ones that can resolve vulnerabilities. And then they have this dotted line here, even getting feedback from production, from say threat visibility and attacks that are occurring. So that's kind of my ultimate secure SDLC, and at my time at Goldman Sachs, we were certainly working towards that, and had made a lot of headway towards that. And then along came Agile. So I highlight Etsy, as Etsy was one of the early pioneers in Agile and CIDC and the shift to the cloud. And so also at my time at Goldman Sachs, they actually happened to be across the East River in Brooklyn. So at Goldman, as I was working with teams that were now embarking on, implementing Agile development processes, we wanted to learn from, experience, right? So organizations like Etsy that have good experience in this space. So I actually organized a field trip, and we did go to Etsy to learn what we can learn from them. And it was very interesting. And some of the things that was a part of the process is actually, developers, they actually could deploy to production, all developers. So they had that capability. They all had a copy of the full Etsy.com website on their laptop, so they, did their development there, their test and validation there, and then they could promote to production. and they could do it whenever they needed to. So that was a bit of a shock for us, obviously coming from a highly regulated environment. But obviously, it's not something we could do. But I think we did learn a few things about their process, and we tried to adopt as best we can in order to achieve this agile development lifecycle. So kind of the results out of that, if we compare to Etsy was deploying code to production 30 to 50 times per day. Now with this agile shift, we, from the security perspective, we had this thought, or this kind of mindset, which is represented in that graph in the middle, which is basically the more you agile, the more you risk, right? Because you're moving code faster. How can we implement, that ML4, SDLC process if they're deploying code 50 times a day to production, right? It's just not feasible, right? Like we would slow everything down. So what we ended up kind of compromising on or coming to at Goldman was kind of the ML3 on the initial code release, right? So doing a full inspection of that, and then applying kind of a more lightweight process as code changes took place. And it was mainly consisted of manual code reviews of the diffs, right? And there was also continuous scanning and things, automated scanning and things like that occurring. And of course, you still had the unit tests and whatnot. So what Agile looked like for us when we got to that point was pushing to production 5 to 10 times per week. So not as fast as certainly as Etsy, but certainly faster than the traditional waterfall life cycles that have been implemented, for years. So that was an interesting experience, and I think for Goldman and in that environment, 5 to 10 times a week was, like I said, not as fast as Etsy, but pretty quick. We did get a lot done there. So that brings us to this next question. This next survey question is, what is your organization's definition of Agile? And I mean, kind of like in frequency of deployments. Do you deploy at least once a day? Do you deploy once a week, once a month, once a quarter, or are you not even doing Agile yet? While you're filling that out, one quick story. Some organization that I talked to within the last year, very large, kind of traditional, long-standing insurance organization, that had for years done waterfall type development. Asking if they were doing Agile. They said, yeah, we're doing Agile. And so I asked the question, well, what does that mean to you, right? Like what's the frequency of deployments? And they say, yeah, we're deploying a new release once every 2 months. And so I think for a lot of people, that might not sound very agile to them, but for this organization, that was vastly quicker than what they were traditionally doing. So that's what Agile meant to them.
And here are the results for that poll.
Okay, great. So, okay, 7% deploy once a day, so they're moving along. And then deploying once a week, 41%, that's good. And then deploy once a month, 28%, all right. And then once a quarter, 3%. And then not doing Agile, interesting, okay. So either doing something else or possibly waterfall there. So, okay, interesting. Great. So there was this shift in thinking that had to come about, and we kind of you got to realize if you're hesitant to move to Agile, or you're in security and you kind of have that same mindset that the more you Agile, the more you risk. But the reality is, with Agile, if you can deploy faster. So if you can deploy faster, you can actually respond to threats faster. But of course, this visibility of threats is required. So I'm sure a lot of us experience, some major vulnerability, is announced in the framework that, is probably used throughout your organization. And, there's a scramble to get that patched. But it can take, in my experience, weeks to possibly even months before you can get through the cycle and the process of patching the vulnerability. So if the organization was set up in a way to move faster with their deployment process, right, that time frame to patch could be cut down to days to hours, right? So there's actually a security advantage to Agile, and I think for a lot of traditional security folks, that's going to take a major shift in thinking, but something we need to be aware of. And kind of, so I have this slide on reality check. So these are some other observations I've had speaking with organizations, and kind of that, the Agile business drivers versus, traditional security practices. So a large California-based data management analytics company, in the midst of a major shift to the cloud, and of course doing Agile development. They tried to implement this new kind of deployment process with the existing security team, but the existing security team was applying their same legacy processes to it. So eventually they hit a point where they're like, okay, guys, you guys have to go back to just covering the legacy systems, and we're going to build the security practice from within our cloud team, because you're just slowing us down, and we're not going to make progress this way. So I thought that was very interesting that, basically the security team got kicked out. But, business drivers, are what take priority. And then, so another organization, a large financial services company, they actually had some special initiatives going on that were explicitly, Agile. And they started out actually not even inviting security to the table, because they knew it was going to slow them down. So basically they said, we're going to get started. You can't see anything. And then once we deploy, then you can catch up, which I thought that was very, very interesting as well. So again, I highlight this because, as especially as security folks, we do need to shift our thinking a bit with Agile. And then if you're not security, you're in the development or DevOps group, then these are good messages to talk to your security friends in your organization with about, and help them have that shift in thinking. All right, so let's talk about threat visibility, the legacy approach, kind of what we've done in the past to try to achieve that threat visibility. Which, and for the most part in production, it was almost, I would say, non-existent for the most part. So you go through the whole process, and then you deploy to production, which is throwing responsibility over the wall, the code over the wall into production. And if there's an issue, developers might say, hey, it's an ops problem, and then the ops people might say, hey, well, it's the security operations team's problem. But moreover, it's just a silo problem, right? Like we have teams that are not communicating regularly, or taking kind of collaborative responsibility in what's happening in production and throughout the life cycle. So, but what we have done, definitely in my experience, right, trying to take advantage of logs to see what's going on in production, right, to get that visibility of these threats that are hitting our applications in real time. But there's a lot of challenges that come with that, right? So just collecting the logs, getting access to them, and even the inventory of what's out there, and then having to put together a centralized log management solution. Very challenging. I think it's getting better in organizations, but definitely in my time, it had its challenges. And then querying that data to try to find threats, right? So logs could be in various formats. You're just trying to do string matching using regular expressions, which is, you're just kind of a guessing game to some extent, trying to find, various, potential threats in that data. It's of course time consuming, takes a lot of resources. You're going to be slow to identify issues, resulting in a delayed response. One story I have there with a colleague at another bank, we were talking about these sorts of things, and he mentioned a recent incident where he's like, hey, we were doing our mining through the web logs, and we found some of these, these strange payloads. We looked into it, and we definitely saw that, yeah, this is a real attack. We looked at the application, and yeah, it's definitely vulnerable. So they validated the fact that, this was an actual attack against a real vulnerability on the site. And I was like, wow. So, how did you stop it? What happened? And his response is, well, we found it 2 weeks too late. So very unfortunate situation, but that's kind of, what you're dealing with trying to get threat visibility from logs in this manner. But in addition, there's as it relates to web applications, there's no post data in many of the logs, unless you do extra logging or implement extra logging, and limited header data. So you won't see attacks that might be embedded in those locations. You just get limited context with these logs, so correlating to other events and things like that can be very difficult. And really the true purpose of logs is just forensic investigation. So, requests came in at this time and got this response and so on and so forth. Now in the background of these bullets, I've got this graph here, so value versus effort. So trying to achieve value here is gonna take a lot of effort, time, money, and resources to start getting value out of it. And even still, you're getting limited value out of it. So WAFs, so these are web application firewalls, and these are another way to attempt to get visibility and potentially even mitigation in production for your web applications. However, they're just well known for false positive and alert overload, and in most cases the visibility is lacking, meaning you either have a central console that you can't really give more than the security admins access to. It's not something you can really delegate out access to share that information with people. It's based on static signatures, which requires tuning, and a lot of it, a lot of tuning to avoid those false positives. And also in the next bullet, breaking applications, especially in agile environments, right? So a lot of tuning is required to not break those applications, but it does happen. And if you're doing agile, you're deploying code, rapidly throughout the day or throughout the week. You've got to constantly be tuning in order to avoid, breaking the application, because new code could release new data patterns coming into the app, which potentially the WAF tool could mistakenly interpret as an attack. So it's got quite a burden there. And then it often gets tuned down just to avoid the headaches. So many times it's just in log only mode. So in that sense, what value is it providing anyway? And then from an architecture standpoint, these legacy solutions have typically not been accommodating for scalability, right? And environments that need to scale, whether it's out to the cloud, on-prem, what have you. A lot of them are appliance based and things like that. So limited scalability there. So, but overall costly resources focused on maintaining it rather than what matters, which is the threats, right? Like you want your resources identifying and mitigating threats as opposed to babysitting a security tool just to keep it from breaking applications and so on and so forth. So again, that graph is in the background here, value versus effort, right? It takes a lot of effort to start getting some value out of it, which is limited. Okay, so I think this brings us to our last survey question. So what has your experience been with legacy WAF solutions? Has it been excellent? Blocked real attacks, no false positives? Has it been mixed? There are good days and bad days? Is it poor? It's a pain to tune, causes issues with the application or users, and you don't put it in blocking mode maybe? Or do you have a fortunate experience where you don't have to deal with a WAF or never had to deal with a WAF?
I'll give a few more seconds for those last few responses. And here are the results of the poll.
Okay, yeah, okay. So 4% excellent. I expected that a little bit to be low. And then 54% mixed. Okay, good days and bad days. And then 11% poor, and then 32% fortunate to not have to deal with it. So, okay, cool. I usually definitely get, a lot of feedback and other, when presenting this, that people do, definitely sympathize with the headaches that, that with that experience with legacy WAF solutions. This was just a funny example I tweeted about a long time ago. So I was looking for something on GitHub. I can't remember what it was, but I came across this commit entry where it says enhancement, prevent blocking jQuery cookie.min.js by mod security by changing plugin file name to jQuery cookie with one o.min.js. So if you're not familiar, mod security is a kind of legacy WAF solution that's static signature based. And apparently it was causing a problem with just, using this piece of code that should be, easily deployed with an application. And the developer went out of his way to change the name of it, which, kind of breaks the application in a sense that you have to, if you're going to upgrade the application or upgrade that library, you have to remember to rename it. And this is just like, this should not be the case, right? We shouldn't have to have these kind of compromises in order to have some level of security, right? So this is just not good. So just to summarize the challenges with legacy threat visibility, one of the problems we operate in silos tend to limited visibility into what's actually happening. The static signatures, just resulting in alert overload, false positives, and breaking apps. The resource spend, you're maintaining a solution rather than mitigating threats. And existing solutions don't scale well, not architected for the cloud or built for the modern web. So moving forward to a new approach in the modern web. All right, so these are the things that we should be looking for in web application security solutions as we embark in this modern web. So as you can see, the graph is vastly different here, right? So we need more value for the effort right away, right? So that's what something should provide us. So it's visibility that informs strategic and tactical decisions. Dynamic detections that eliminate the false positive problem, blocking that does not break production traffic, to be able to go above and beyond OWASP type of attacks, and we'll dive into these more in a little bit. It has to be easy to deploy and scale with modern architectures. Needs to enable automation and integration, which is important with all the other tools that we work with, and also flat out being able to automate things to help your team scale. And these require little to no resources to manage and maintain. So to speak to visibility that is strategic, this is being able to see what type of attack traffic your apps are seeing or experiencing, and which parts of the apps are being targeted. So knowing that is actually very important. And then also anomalous traffic, right? Like what type of anomalous traffic are you experiencing? And so we need the answers to these questions, because this is feedback to your AppSec program, right? To help with prioritization and efficient use of resources. So for example, if you know that, hey, this part of the application over here is seeing 80% of the attack traffic, then that's good feedback to your AppSec program and your developers to know that, hey, we need to make sure the code in this application or this part of the application is hardened, has passed all its checks and follows secure coding practices. So when you get those long lists of vulnerabilities, that report thrown at you, if you actually knew which parts of the app were being attacked the most, that would help you actually prioritize that vulnerability list, right? Because you have limited resources and time, and you need to be able to prioritize those things. So visibility that is tactical. So this is about having the ability to expose security data to DevOps to foster involvement, right? So your developers, operations, not just security. So this is, having the data displayed on dashboards that or that might be on the TV up on the wall, and along with the developers or operation teams, and integration into the DevOps tool chain. So really, the tools that the DevOps folks are using throughout their day, right? Like the security solution should just be a natural part of that. And then of course, APIs for automation and integration into other monitoring solutions. One thing I'll say about the, having that TV display and how that helps to foster involvement. So if it's there, persistent every day, people come into work, they see that every day, they're watching it. If they ever, and they'll get accustomed to what's normal, right? They'll kind of understand what's normal behavior over time. And if they ever see a spike in that graph or a deviation to what's normal, they're going to immediately want to jump in and find out what's going on, right? So that's a great way to involve everybody in the security story. And also, it benefits them as well to know what's happening with their applications. Cool. So detection and blocking. So we need detection that does not require tuning and enables agile development. So kind of what does that mean? So dynamic detection of attacks, right? So doing away with these, regular expression-based static signature type solutions, something that's more just dynamic, that doesn't require tuning. Throttle blocking, so taking a throttle-based approach, before reaching a decision to actually implement a block against a request, right? Because, a user could, type something that might be interpreted as an attack, but it's actually legitimate data coming from a legitimate user. And if you were to try to block on every single instance of that you've detected as an attack, you just blocked a legitimate user. So a throttle-based approach actually bubbles up the actual attacker who's actually trying to discover a vulnerability on the site by sending test attack payloads and things like that. And then only blocking requests that contains attacks, right? Like you don't want to block an IP outright because that IP could be fronting a mobile gateway or corporate proxy. You don't want to lose all those legitimate users behind that proxy just because there's one bad actor behind that. So only blocking the requests that contain the attacks. And then complete decision transparency, right? So if blocking does occur, developers and operations, they need to understand why if they need to look into it. So if we see this example timeline here, right? So, something being marked as suspicious, and then it's reached that threshold, right? So in this case, we saw 7, attacks within 1 minute. So we flagged that IP for blocking, the blocking decision's made, and then any subsequent requests were then blocked from that, right? So having that kind of visibility of, what transpired and also being able to dig in and actually see the requests that are being blocked, that's huge, right, for everybody to understand what's going on and to be able to determine, any further action if necessary. Cool. So business risk, right? So this is really about going above and beyond the OWASP injection attacks. And so by OWASP injection attacks, I'm referring to like SQL injection, cross-site scripting, command injection, things like that. But account takeover is, I think probably one of the larger threats that a lot of applications face today. So we need to be able to need a solution that can address those things. But also getting visibility to high-risk transactions, right? So starting to address the business risk with the application. So in these examples here, we have, financial services example, understanding every time an account link, so users linking their bank account with the application, or there's a funds transfer, money movement going on. And then also, e-commerce, gift card redemption, add profile changes to the user, things like that. So in this kind of example here, you see order fail, right? So you have a spike in order fail, right? So having visibility in an order transaction failing could indicate, either a problem with the application or an attack, right? So that visibility becomes very crucial. Even think about healthcare and patient records, right? So accessing patient records. And of course, bots, right? So, and that probably falls in line a little bit with the account takeover that's typically driven by bots, but bots are doing other things as well as far as scraping and things like that. So definitely something a solution needs to provide mitigation for those types of threats. And what this boils down to really is being able to instrument your application for security. And to kind of touch on that a little bit more, instrumentation, but also correlation, being able to tie different things together, different events together, right? So by this, I mean, and as an example, an attack plus an anomalous response. So say a 500 error code, right? So if you see a SQL injection payload and that responded in a 500 error code, that's a key correlation to be alerted to because that means someone's identified a flaw in the app and they're actively trying to exploit it. And that's something you want to see and determine whether you need to take further action on. And also attacks against sensitive high-risk transactions. Distinct changes in traffic patterns, but also automation, right? So bots that might be driving user actions in an application. So if you have a form that should only be filled out by a human, but you're seeing, indications that a bot is attempting to fill out this form, then that's something you want to be alerted to. So again, it's about being able to instrument your application for security and really getting into the business risk associated with the app. So to kind of summarize it, we need visibility that enables defending your applications in real time because you can't defend against threats you can't see. So another piece that of the puzzle for a solution in this space is scalability, of course. It needs to be able to scale across multi-cloud and on-prem, a frictionless deployment, right? It has to be easy to deploy. Otherwise, the app teams will be resistant, to cooperating and deploying the solution. And if it's easy for them to deploy, then they're going to be very happy to adopt it, right? Because dev teams, they want to have security as well, of course. And it needs to work regardless of app stack or language, right? So you can't be constrained to making trade-offs, the solution can cover maybe 75% of our applications, but we'll have to forgo or do something else for the other 25%. That's not a good trade-off. And of course, it needs to be performant and reliable. I do like to highlight, in talking about modern cloud platforms, I do like to highlight actually Cloud Foundry, which is pivotal Cloud Foundry, because I like, they have a phrase or kind of a statement of rotate, repave, and repair. And really what that's about is rotating credentials frequently. Repave is about disabling persistence. So that means if you're recycling instances, the images periodically, if an attacker ever gets hold of a particular instance and it gets recycled, then they just lost their persistence, right? They have to start all over again. And then repair is being able to patch immediately, right? Like being able to patch your infrastructure at a click of a button. And so I highlight this because this is really about being agile in production. We need to keep moving. And we should look for any cloud solution we're using or going to adopt. We should look for these capabilities within them and definitely take advantage of them. So to summarize that, we need to continuously increase the cost for attackers. So and a bit of closing here. So we've kind of talked about these concepts, and I hope you agree that these are the things we should look for in a solution as we apply that to our web applications. And so, what solutions are out there for this to achieve this? Well, you can engineer, your own solution for instrumentation to achieve this. I reference here actually it's relatively old now, 2011, but actually Etsy, the company I referred to earlier, they have some blogs. This is their blog. They talk about measuring things and instrumenting their applications and how they've done that. And there's a presentation here as well. But again, going back to that value versus effort, right? To start getting good value out of it, you've got to put a lot of effort, so time, money, and resources into it. And so maybe that's okay, but maybe that's something you don't have. You could start with some open source projects that are out there and engineer around it, but you're in a similar situation where there's a lot of effort involved to start getting good value out of it. And even though it's open source, it's not exactly going to be right-sized for your environment or your applications, and every application is different. So you kind of have to engineer around that. And of course, there is Signal Sciences, which is an option for you. And Signal Sciences does certainly provide that value right away out of the box with little effort. So that brings us to the end of the presentation, and definitely would like to open up the questions. But I hope you found this informative, and if you're not looking at solutions that meet the criteria I outlined, then any solutions you're looking at, I hope you start applying those criteria to it.
Great. Thank you so much, Philip. We do have a few questions that have come in. Our first question is, which would you say is a bigger threat, injection attacks or attacks on business logic?
So certainly injection attacks are important, and you need to pay attention to that. But I in my experience, definitely in working with customers today, across the board, the attacks against business logic far more outweigh. I mean, these teams are just battling battling these things, very periodically, especially when it comes to account takeovers, so credential stuffing attacks, things like that. Attacks against their high-risk transactions, so it could be like credit card validation or other kind of financial transactions, and scrapers and so on and so forth, and certainly bots come into play there. So I definitely think the larger threat is that of the attacks against business logic, but also just automated attacks as well.
Awesome. Our next question is, how can a modern web security solution scale across multiple environments, on-prem, cloud, etc.?
Yeah, so it definitely needs to be flexible, right? And how it can be deployed, because typically you'd want to. It would be deployed close to the application, so either part of the app stack, which could be the web server, it could be at the code layer or what have you. So in that sense, it could be baked into as part of the image. As a lot of people are using, for example, Kubernetes. Just baking that solution in, so that's going to just seamlessly scale, whether you're using, containers in Kubernetes or VMs or what have you. But I think you also need an option where, what I just described doesn't apply, but you need an option for some kind of reverse proxy type deployment, to get that coverage in areas where, you're not able to deploy the solution closer to the application or within the application stack. So having that flexibility to deploy close to the app in the stack, or as a reverse proxy out in front of it, I think that's definitely how you scale across multiple environments.
Great. The next question that we have is there a tool or way for automatically checking for updates to third-party libraries?
Yeah, definitely there is. There's actually, in my slides, I actually referenced an OWASP project, which is called Dependency Check or Dependency Checker. That's an open source tool, and it's fairly good at doing that. So I definitely, if you need a place to start, you should start there. But there are definitely other vendors out there that do this as well. I guess just off the top of my head, Black Duck, Sonatype. I think those play in that area as well.
Awesome. The next question that we have is, how is RASP used throughout the application?
How is RASP used throughout the application? So the way I look at RASP, and actually, if you go to our blog site, I actually have a blog write up on my thoughts on RASP. So I think people think about RASP and they kind of have an idea in their head about how it works and what it does. when you say RASP. But if you just take the term itself is runtime application self-protection, right? So that doesn't necessarily mean it's implemented directly at the code layer. It could be something at a layer above that, like the web server layer, right? So it's something that is providing that protection against attacks in real time, right? So I think it's just, if you deploy it at the code level, whatever that solution may be, I think that's where a lot of folks, tend to think, refer to that as RASP. But even if you deploy it at the web server layer, I would still say that's, runtime application self-protection, right? So I hope that answers the question. But like I said, I have a blog post that talks more about that if you want to read up on that. And that's at the labs.signalsciences.com.
Great. The next question that we have is, how can you have dynamic detections without signatures?
So yeah, I mean, definitely at Signal Sciences, we have an approach to that, which we call Smart Parse. But basically what it's doing is data's coming into the application. It's tokenizing the data that's coming in, and then basically doing like a lexical analysis or a syntactical analysis to validate it for actual syntax. For example, for a SQL injection attack, is it legitimate SQL? Like, would this actually, compile and execute, in a database? So by taking that approach, that tokenization approach, you get a higher degree of accuracy in detecting real attacks, right? So, and that effectively eliminates the need to try to, develop, a huge list of regular expressions or static signatures to try to identify all the different variants of SQL injection or the different variants of cross-site scripting. So that's how at least, we solve that.
Awesome. We do have one more question. So audience, if you do have any more questions, please post them into the questions panel. The next question that we have is, how important is it to have an API for a solution like this?
So I think definitely it's not a showstopper, but it is huge. There's a huge advantage to it, and because there's so much more you can accomplish with an API. So whether that's just integrating with your SIEM solution to get the data, of course, or other like incident management systems, to intake alerts and kick off the process with that. But also you have other security tools in your environment, right? So being able to integrate with those could be a distinct advantage for scalability, for one. So for example, if you have your IDS, IPS, right, and they detect an IP and determine it to be malicious, right? So being able to take that information and then add it, in an automated fashion to your web application layer, and to have protection against that malicious IP, and then vice versa, right? Like your web application layer picks up a malicious IP, and then you'll be able to add that to your list in your IDS, IPS, just as an example. That's a huge advantage, right? So having APIs enable that, right? So I think it's very important. And so also, being able to easily query the data for analytics and, any other further automation for threat hunting, for example. Just another example, a customer example that uses Signal Sciences data, they actually have a broader anomaly detection engine that's taking inputs of data from various sources. And so they're pulling that data via our API into that system. So we're one input into that system. So having just that access to the data, the extensibility and the capability to automate, it kind of, to summarize it, I think it really helps you scale because we all know we have limited resources, limited time. So anything you can automate is a huge win.
Great. We do have one last question. That question is, are we missing anything by not doing code reviews often?
So are we missing anything by not doing code reviews often? So there's a couple types of code reviews. There's manual code review, and then there's automated static analysis. So with manual code review, my experience was that we really found the most bespoke bugs by doing manual code reviews. In some cases, they were things that potentially could have been exploited by an attacker, but in other cases, they maybe were not so easily exploited. But you could see a broader issue with that, and also you could pick up coding patterns right from your developers. So you kind of get a sense of how they're coding, and then at that point, if they're kind of not following good practices, then it becomes a good education session with the developer, an opportunity to educate the developer. So I think manual code reviews, you can't possibly do all of it, but if you do it, at some level, even if it's just minimal, you actually can get some really good value out of that. And then with automated code scanning or code reviews, I mean that's you end up with a lot of findings. I tend to want to tune that scan down to just very specific classes of vulnerabilities and risk levels, and try to clean that up first, and then go on from there. So I hope that answers the question.
Great. Thank you so much, Philip. Is there anything you would like to add before we close things out?
No, just thank you everybody, and definitely look me up online, whether it's through GitHub or on Twitter. Reach out to me. I'm always happy to answer further questions if you reach out to me through those channels. And yeah, just thanks everybody.
Great. And Philip, I'd like to thank you for a great presentation today. I'd also like to thank today's sponsor, Signal Sciences, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.